Alright, so we're back, and here we go. Let's talk about why is it that when we did this probability of the kids, we got 0.0264. Oops, start this. And the calculator got 0.2637 or something like that. 0.2637. And really, we're off by a multiple of 10. And why is that? And the answer to that is simply because when we set this up, there's a 0.2637. When we set this up, we did this originally. Let's insert a new page here. So that what we had is we had a kid had typo blood. We had a kid who had typo blood. We had a kid who, let's see, we had 2 kids with, and then we had typo not, and typo not. But realistically, what this is saying is the first 2 kids have typo and the other 3 don't. But is that the only way I can do this? Because what I could have the first kid be typo and the second one is not. Then we've got typo and typo not and typo not. Or I could have typo and typo not and typo not and typo and typo not. Or I could have typo and typo not and typo not and typo not and typo. Or I could have not typo and O and not typo and not typo. Or not typo and O and not typo and O and not typo. And so forth and so forth. I could do that for a while. And there are 10 different ways that you can do that. And this is the combinations, the number of combinations I come up with having 2 successes and 3 failures. And that is 10. And that is a combination. So let's go on here, and I love this part right here. This is like my favorite thing ever. Okay, suppose I have a group of 4 students and I want to choose one of them as a volunteer. And how many ways can I choose one out of 4 students? Notice that I am choosing you to volunteer. All right, so here we are. I like this. I call this the garage door of knowledge. Ready? So in how many ways can I choose 1 out of 4? And the answer is there are 4 ways. And we call this 4, the number of options, choose 1 success. 4 times, 4 sample sizes, 4, choose 1. There are 4 ways. So I can have success and not, or not success and not, or not success and not, or not success. Suppose I have a group of 4 students, I want to choose 2 of them as volunteers. How many ways can I choose 2 out of 4? Saying, saying I want 4, choose 2. 8, you say. 8? No, there are 6. I can have success, success, and not, or success and not, success, not, success, not success, not success, success, not success, not success, not success, success. There are 6 ways I can do that. All right. Suppose that I have 5 students. I want to choose 1. So what we're talking about is 5. Choose 1. How many ways can I do that? And you're saying 5, and you're right, and I'm not going to read it because it's starting to get annoying. I understand that. Okay, let's go down and say that I have 5 and I want to choose 3. How many ways that I can do that? So 5, choose 3. 5, choose 3. There are 10 ways that I can do this. Now, okay, fine. I could probably actually figure these out by hand. What would happen if I had 20 and I want to choose 4? 20, choose 4. I can have success, 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 success. No. There are 4,845 ways to do this. How do I do this? Well, when we talk about n choose k, okay, which is I have n and I want to choose n sample size, I want to choose a certain number of successes. Remember in your calculator, we had n and r, and then we had p in between, where r was the number of successes. In the general term, everybody else except for the calculator uses the letter k. And we write this, and this is called the binomial coefficient. And this is the number that we actually put in front of that multiplication that we did, which was 0.25 to the second, 0.75 to the third. N choose k, where n is the number of successes and k, or n is the number of trials and k is the number of successes. for us particularly, we have 5, we want to choose 2 kids with type O blood. 5, choose 2. Now, the formula for this is you do n factorial over k factorial times n minus k factorial. And that looks like it's a mess, remembering that factorial is a value, a number n, multiplied by every positive integer less than itself. So this would be actually 5 factorial, which would be 5 times 4 times 3 times 2 times 1, over k factorial, number of successes, 2 times 1, times n minus k factorial, which would be 5 minus 2, which would be 3 factorial, 3 times 2 times 1. So actually what happens is this is the number of successes, this is the number of failures. Now, what typically happens is things start canceling out. 3 times 2 times 1 cancels out. 2 times 1 is 2, and that reduces with 4 to 2, and you get 5 times 2, which is 10, which is why we said we've got 10 of those ways to do that. So, that brings up now the binomial formula. Let's skip in this, because I don't really want to know that. The binomial formula. And this formula is in the formula sheet. And you don't have to know it to write it like this, but you have to know it to use it. And there are some very important things. Now, it looks complicated, but it's really not. Okay? And here's how it's going to write with us. We've got 5, we're going to choose 2. Okay? N choose K, 5 choose 2 successes. Probability, P is the probability for success. The probability for success for us is 0.25. Now, these are the only 3 numbers you need to know. And these are the 3 numbers, NPR, that goes in your calculator. From these 3 numbers, everything else falls into place. Because notice, this is N choose K, then this is P to the K. Probability of success to the number of successes. These 2 values are always going to be the same. I have 2 successes. 2 and 2, always the same. Then comes 1 minus P, which is the probability of failure. 1 minus P, well, if success is 0.25, failure is 0.75, the complement. All right, then this says N minus K. What is that? That these 2 values subtracted. The number of trials minus the number of successes, otherwise known as the number of failures. So, this is going to be the number of failures. Now, notice these important relationships here. Let's get that pen out of the way. Here is the number of trials. Here's the number of successes. Here's the probability of successes. These are the only 3 numbers I need to know. I need to know these 3 numbers. Number of successes is the exponent for the probability of success. So, these 2 numbers are always going to be the same. 0.75, 1 minus P, this is failure. These 2 numbers, 0.25, 0.75, are always going to add to 1. So this is the complement of success. This is the number of failures. And these 2 exponents are always going to add to the number of trials. Because if I have 2 successes, I have to have 3 failures. If I have 1 success, I have to have 4 failures. If I have 4 successes, I have to have 1 failure. These have to add up to 5. And that's what's going to make this fairly easy. Now, how do I do this? You don't. You don't have to do this. You could do this in a calculator with NCR. But this right here, this is the binomial PDF. The binomial PDF of NPR, which are these 3 values right here. So what you have to write is this. When I would ask you this question on a test, what's the probability of getting exactly 2 kids out of 5 with type O blood? You will have to write this. You'll have to write the binomial formula with the values in place, showing that you know how it works. Then you can use the calculator and use binomial PDF N, P, R, and just get the results. And you can say is equal to 0.2637, if that's what it was, if I remember right, 0.2637, and that's all you have to do. If you write binomial PDF and you put these values in, you say equals, and that's it, you're not getting credit for it. You're not going to get all the credit. You'll get some credit for just the answer. But you need to have this right here, binomial formula written this way, and then you can give the answer. And if you want to then write binomial PDF, NPR, that's fine. Calculator speak itself is not enough of an answer. You need to write the formula, and then you can turn around and do calculator speak. Okay, now we are at the point we're done here, and we're going to talk about taking this and turning it into a normal model next time. All right, so this will actually be tomorrow because I'm done, I think. Aha.